Good morning. As the sun rises over the horizon, it illuminates a new era in transportation, one that promises to reshape not just how we drive, but how we think about energy, technology, and the world around us. We often imagine revolutions as grand, sweeping changes, massive factories humming with activity, cutting-edge technologies rolling off assembly lines, and bold policies announced with fanfare. The electric vehicle revolution fits this image perfectly, with sleek Teslas and Fords gliding silently off the line, each one a symbol of hope for a cleaner, greener future. But sometimes, the most profound disruptions don't come from the big, flashy innovations. Instead, they emerge from the tiniest, most overlooked parts, components so small you could easily miss them. This is the story of a tiny, yet incredibly powerful magnet, so essential to electric vehicles that its absence could bring America's entire EV ambitions to a grinding halt. It's a story that stretches far beyond the factory floor, touching on global trade, national security, and the hidden vulnerabilities in our most ambitious plans for the future. The issue at hand isn't just about cars, it's about the fragile, interconnected supply chains that quietly power our entire economy, often unnoticed until something goes wrong. For decades, we've chased efficiency, sourcing components from wherever they're cheapest, building a global web of suppliers that seemed unbreakable, until now. But this relentless pursuit of cost savings has created dangerous dependencies, leaving us exposed to risks we never fully anticipated. Now, a looming tariff on permanent magnets, those tiny but vital components, has sent shockwaves through the auto industry, threatening to disrupt production lines and unsettle markets. This isn't some distant, hypothetical threat. It's a real and immediate risk to production, to prices, and to America's strategic goals for clean energy and technological leadership. How did we become so reliant on a single source, often halfway around the world, for such a critical part? And more importantly, what can we do to regain control? The answers are complex, involving a mix of engineering challenges, economic realities, and geopolitical maneuvering that few outside the industry ever see. Automakers are scrambling for solutions, policymakers are locked in heated debates, and consumers, perhaps unknowingly, are caught in the middle, waiting to see what happens next. The choices we make now, in boardrooms and government chambers, will determine whether the EV revolution accelerates as promised or stalls, all because of a component that fits neatly in the palm of your hand. To truly understand this challenge, we need to look beyond the gleaming showroom and dive deep into the heart of the electric motor, where the tiniest magnet casts a giant shadow over the future of mobility. The critical component at the heart of most electric vehicles, high-performance neodymium iron boron permanent magnets, which are among the strongest magnets ever created by humans. These powerful magnets are the silent heart of most EV motors, enabling engineers to design motors that are not only compact and lightweight, but also incredibly powerful and efficient. Their exceptional magnetic strength allows for smaller, lighter motors, an essential factor for maximizing driving range and overall vehicle performance, while also freeing up space for passengers and cargo. Without these advanced magnets, electric vehicles would need much larger and heavier motors, making them less efficient, more expensive to produce, and, ultimately, less appealing to consumers. Permanent magnet motors convert battery power into motion with minimal energy loss, which is why EVs can deliver such impressive range and provide that signature instant torque when you press the accelerator. If automakers had to replace these magnets with weaker alternatives, it would mean using bigger, heavier, and costlier batteries, making electric cars less practical and more expensive for everyday drivers. But manufacturing these high-performance magnets isn't simple. They require rare earth elements like neodymium and dysprosium, which are difficult and expensive to mine and process. The global supply chain for these critical materials is highly concentrated, with China dominating both the mining and processing of rare earths, controlling the vast majority of the world's supply. For years, US automakers have relied on cheap, steady imports of these materials. But that reliability is now in question, as geopolitical tensions and trade restrictions threaten the flow of rare earths. The auto industry is waking up to the reality that the very heart of its electric future is controlled by someone else, and that this dependence could put their entire business at risk. This dependency on foreign-controlled supply chains is a major vulnerability for automakers and for the future of electric vehicles. The stakes couldn't be higher, as the race to secure these vital materials will shape the future of transportation for decades to come. Now, Imagine the impact of a sudden 200% tariff slapped on Chinese permanent magnets, an essential component in electric vehicles and countless other technologies. Overnight, the cost of magnets for a single EV motor skyrockets from $50 to $150, tripling the expense for every vehicle rolling off the line. For automakers producing 1 million EVs, that's a staggering $200 million in unexpected new costs, added instantly, with no time to prepare or adjust. Companies like GM, Ford, and Tesla, already squeezed by razor-thin profit margins, are suddenly forced to make tough decisions. Do they raise prices for consumers, absorb the losses, or slow down research and innovation to cut costs? Production planning is thrown into chaos, as long-term supplier contracts are rendered useless and budgets are blown apart overnight. With alternative suppliers for these specialized magnets scarce and hard to find, automakers are left with very few viable options to keep production running smoothly. The result? Potential production slowdowns, factory layoffs, and higher sticker prices for American consumers, making EVs less affordable just as demand is rising. Meanwhile, foreign automakers not subject to these tariffs could swoop in, undercutting US brands both at home and in global markets, gaining a competitive edge. Ironically, a policy designed to protect American industry could end up making it less competitive, at least in the short term, by increasing costs and reducing market share. The risk is real and immediate. America's ambitious plans for EV leadership could be derailed by a single, massive supply chain shock. The entire industry is on edge, watching the clock, knowing that every second counts as they scramble to adapt to this new reality. Why not just switch to a different motor design? It's not that simple. Redesigning a motor takes years and hundreds of millions of dollars. Motors are deeply integrated with a vehicle's battery, electronics, and software. Alternatives like AC induction motors or externally excited synchronous motors exist, but they're less efficient or more complex. Switching would mean heavier cars, shorter range, and costly retooling. Most new EVs are already designed around permanent magnets. Changing course now would waste billions and delay new models. The industry can't pivot overnight. For the next several years, permanent magnets remain essential. The challenge is finding a way to secure them. Automakers aren't the only ones desperate for magnets. Wind turbines, defense systems, consumer electronics, and medical devices all compete for the same limited supply. Wind turbines alone can use over a ton of magnets each. The Pentagon considers magnet supply a national security issue, often taking priority in a crunch. Every smartphone, laptop, and MRI machine needs magnets too. This cross-sector demand means building more factories isn't enough. We need to scale up mining, processing, and recycling. Any disruption sends prices soaring and intensifies competition. Automakers aren't just bidding against each other, they're up against energy, defense, and tech giants. The battle for magnets is fierce. The stakes, the future of multiple industries. The supply chain is stretched to its limits. What can automakers do right now? First, secure existing supply, lock in contracts and, if possible, stockpile magnets, diversify suppliers, even if options outside China are limited. Some are signing direct deals with rare earth miners in Australia, Canada, or the US to control raw material flow. These moves buy time, but they're expensive and only partial solutions. Automakers are also lobbying Washington, warning that sudden tariffs without alternatives could devastate jobs and production. They're pushing for phased tariffs or incentives to build up domestic supply. The message: give us time to adapt or risk stalling the EV transition. The industry is in crisis mode. Every decision now shapes the future. The real solution? Build a domestic magnet supply chain. The US has rare earth deposits like Mountain Pass in California, but needs to ramp up processing and manufacturing. This requires major investment, public and private. Government incentives and long-term automaker commitments can help de-risk new factories. Recycling is also key. Old EVs, wind turbines, and electronics are rich sources of rare earths. A robust recycling system buffers against supply shocks and reduces environmental impact. Building this ecosystem will take years and billions, but the cost of inaction is higher. The current crisis is a wake-up call. America's industrial future depends on resilient supply chains. It's not just about cars. It's about national security and technological leadership. The time to invest is now. Long-term, the goal is to design our way out of dependence. Automakers and researchers are developing motors that use fewer or no rare earth magnets. New materials like iron nitrogen or manganese aluminum magnets are in the works. Modular vehicle platforms could allow easy switching between motor types as supply shifts. Smart phased tariffs can encourage domestic investment without crippling industry. Policy should align with industrial timelines, acting as a catalyst for innovation. The future is about flexibility, adapting to shocks, not just surviving them. America's competitiveness depends on it. The EV revolution's fate rests on tiny magnets and the big decisions we make today. The story isn't just about supply chains, it's about building a resilient future,